Okay, so let's talk about the final exam first. And when is our final exam in here? Tuesday at 10:10. Let me confirm that on my calendar. Tuesday at 10:10, 250 final. So, final exam, Tuesday, 10:10 a.m. So you'll have whatever, the hour and 50 minutes to take the exam. The exam will be very similar to the midterm. That is 10 questions, each worth 10 points. The length will be similar to the midterm, so you should be able to complete it in around an hour or something like that, but you have the full 2 hours to do it, so it shouldn't be a time crunch issue. So you should have plenty of time to show me what you are able to do. So what I'm going to do is I'm going to walk through the slides, kind of tell you what I deem to be fairly important and what's less important, so you know where to focus. Technically, everything we've done this semester could be on the exam. Certainly, you're going to need to do for loops and all that jazz on the exam, so you're going to need to know the basic stuff, but I probably will have a heavier focus on the things we've done since the midterm. Okay. As far as the extra credit tokens go, I know some of you have emailed me saying, oh, I want to apply it to this, I want to apply it to that. It's fine. What I'm going to do at the end, you should see on the grade book that there's the tokens are listed there, how many you earned. I'll apply it to wherever it's going to best benefit you after all is said and done. Okay, what's going to give you the best impact for your final grade. Okay, so you can rest assured that that'll, but you don't have to email me. Yeah, I will apply it to how it's going to help you the most, whatever that is. Because, you know, when people emailed me before and said, oh, I want to count this for quiz number 7 or something like that, well, things might get worse after that. So I'm just holding them off till the end, and once I see the final grades, I'll go back in and I'll spend your currency and see where it benefits you the most, and that will hopefully impact your grade definitely impact it in a positive direction. Hopefully it's enough of a positive direction to flip from a B- to a B or something like that. Okay. So we'll just kind of flip through all the slides. Obviously, you need to know what Java is. I probably am not going to ask you anything about the Java virtual machine, kind of old news. You know, comparing it to C#, fine. Probably won't ask you anything about that. The idea of CPUs being kind of a collection of magic tricks, also important. Probably won't ask you anything about that. You should have that understanding of how humans solve problems, memory, asking questions, and repetition. That concept could come up on the exam in some form, one way or another. So that's kind of an underlying concept that goes through all of my programming classes. That comes up over and over again. The whole 2 kinds of programming language stuff, also important information, probably won't make it onto the exam. Low priority, but there could be some question about primitive types. I could ask you some, because I like conversion type questions, so I might ask you to convert between some numbers, or I might ask you if an int is a 32-bit signed integer, what's the smallest and largest number it can hold, something like that. So it'd be plus or minus 2 to the 31st power, because it's 32 bits and one of the bits is used for the sign, something along those lines. Again, pretty low priority. I would have to be fishing for an extra question to pull something like that out. I can almost guarantee you, though, there'll be a conversion question, like, you know, convert 123 in octal to hexadecimal or something like that. I like conversion questions, so there'll probably be at least one of those. Again, you should know what the Unicode character set is. Pretty low priority. That'll be on there directly. Potentially, I could ask you a programming question that might require that you understand that chars are actually represented as integer types that map to the Unicode set. I might ask you to do something funky with doing math with chars. So like an A plus 2 is a C, that type of thing. Again, the concept, all programs begin and end with main. I don't know how I would work that onto the exam specifically, but it's something you should definitely know. That kind of fits into our model more recently with objects, where we have one program that kind of has the main method in it. Or with Android, our main method from our perspective has been the onCreate kind of guy. But then we have some objects that we've made on our own, like person or patient. Those guys don't have a main in it. They're not meant to be run directly. They're meant to be representative of objects that we then use for other things. So that's the purpose of those guys. Certainly the idea of a pointer, so something capable of holding a memory address, what that means. I certainly could, there will probably be some sort of question on the exam dealing with pass by value or pass by reference. Maybe taking an array in as a parameter, making some change to the array and asking you what the final value of it might look like. So I might give you some code and ask you what the output of this program is, and you'll have to show me that you understood that something was passed by value or passed by address, so you knew whether it was changed in the original memory location or whether a copy was being changed. It's back to that example of I'll give you a can of spray paint, I tell you where the address of my house, and you go and spray paint the garage. I'll find out about it when I get home. If I give you a copy of a quarter and you go and spend it, nothing's happened to the other quarter that's in my pocket. Definitely be able to work with strings. We'll have plenty of strings on the exam. Here's a conversion example. Obviously, you should be able to create variables, work with them. Plus, plus, minus, minus. I probably would not ask a question having you differentiate between A++ and ++A. But that is something you should definitely know, at least from a reading code perspective, that A++ boils down to the current value of A and then increments A, whereas ++A increments A first and then boils down to the value. So understand that these guys are not exactly equivalents, but they're extremely related to each other, and I've kind of taught the idea of nobody's impressed if you squeeze extra stuff onto a single line. Instead, if you want to make A one bigger than it used to be, put it on its own line and move on with life. Then it doesn't matter which of these three things you do, because you're not using the value directly. Idea of asking questions. What's a Boolean expression? I could see, if I'm, there will definitely be a question on there in some way. It's going to test that idea of, how do we call class methods? How do we call instance methods? What's a Boolean expression? That's going to get on there one way or another. Just that high level, almost vocabulary stuff. What are the three things that live inside of a class? Fields, constructors, methods, those types of questions. So there's kind of a set of vocabulary that should be common to all of us, as opposed to just some random stuff that we haven't really discussed or I maybe brought up. So things that we've had a cadence in class where I've said, how do you call class methods? Using the name of the class in which the method's defined. If we've done a little sing-songy thing with it, it's probably important. If we don't have a sing-songy thing with it, probably not as important. Okay, so I probably won't ask you anything about vocabulary that we haven't attached to some sort of sing-songy thing to. Certainly be able to work with loops. Pretty low priority, me asking the difference between a pre-check and a post-check loop, but it would be in the realm of possible. I could ask a question like, what are the three kinds of loops and what kind of problems do they lend themselves to? For loop, while loop, do loop. Do while loop, for loop lends itself to counting problems. While loop lends itself to problems where we're not sure how many times it runs. Do while loop lends itself to problems where something happens at least one time. That kind of stuff. But again, for the final exam in here, I would have to be fishing for a question. So I would be surprised if something like that specifically ended up on there. Certainly be able to write functions. Pretty much every programming question on the exam is going to be write a method that does this, write a method that does this. There'll probably be maybe one question that has you maybe write an object or write a constructor or something like that. But I'm going to be kind of measuring a couple of different things on the exam. I want to know what your problem-solving ability is. That is, here's write a function that accomplishes some task, takes in a string and reverses it, that kind of stuff, to show me that you can A, write competent code, B, you can solve relatively simple problems. So you can break down those things and come up with algorithms for solving them and convert them into, in our case in here, Java. But those types of questions, I'm testing something different than when we're looking at, create an object that can represent a patient where a patient has a first name, a last name, and an age or something like that. In that you're not really implementing an algorithm as much as you're implementing a storage container or a variable type. Does that make some sense? And then you might give abilities to that guy, and those are your functions that might do something that, algorithmic. But other than that, when you're creating an object that can hold something, that's kind of testing a different type of competence. So definitely be able to write functions. If I give you something, it's almost like the word problem version of a math test. So I'll give you a question probably written in English, and you'll have to make sure you give me the correct return type, write the method header the right way, write the right correct parameters. I mean, those should be all given easy stuff, because that doesn't require you to come up with the actual solution to the problem. It requires you to come up with the idea of what kind of value does it return and what kind of values does it need in order to do its job. So you should be able to write the structure of a function perfectly. Now, maybe your logic becomes a little sketchy, but the structure of the function itself should be perfect. What's a class? We've been working with them a lot more recently, so classes will be represented on the exam. Understand the difference between class methods and instance methods, class fields and instance fields. Certainly know about the modulus operator, percent symbol, that gives you the remainder of whole division, of integer division rather. So like 5 divided by 4, 4 goes into 5 one time. All right, so let's do 5 divided by 3. 5 divided by 3, 3 goes into 5 one time. 5 mod 3 is 2, what's left over. Okay, 3 times 1 is 3, plus 2 gets you to the 5. So that gives you the remainder of long division is the modulus operator. Definitely be able to work with ands and ors. Be comfortable working with strings. Be very aware of our little convenience thing of concatenating stuff onto the empty string to turn primitive types into strings. Somewhere in there, you're going to have to use that little trick. So, and that should be kind of a go-to move for you. Probably won't ask anything about compiler specific. Definitely static versus non-static, one way or another, is going to be represented on there. This is when we were talking about data representation languages. Probably will not ask you anything about that on there. I mean, you should be aware of them, but I'm not sure it's going to fit with anything I intend to be testing you on in the final. Again, definitely know what primitive types are. I probably will not ask you specifically what's a primitive type, but you should certainly know what they are, be able to work with them. Primitive types: byte, short, int, long, char, float, double, Boolean. So those are our primitive types. You should know what those guys are. Pretty low chance that I'll ask you to list all of them, but you should certainly be comfortable working with primitive types. So I would say there's a very low chance I'll ask you to list them all. There's a 0% chance I'd ask you to tell me what the size of each one is. Like a byte is a signed 8-bit integer, that kind of stuff. You should sort of have a pretty decent idea where you can maybe come up with that if you had to, but that's relatively unimportant information in the big scheme of things, other than like a long can hold a bigger value than an int. Sometimes you might be using numbers that are so large that you're kind of bumping up against that limitation, in which case you would go and fix it, but not something you really need to memorize for an exam. That's not what I'm trying to test. At the end of the day, if you want just kind of an overarching thing of what I'm trying to get out of the final exam, it's not meant to be a punishment. I want to see what your current competence level is relative to where you should be coming out of the course. So I'm not going to be trying to trick you on the exam because I don't want you to arbitrarily lose points because you missed some like weird, zig when you should have zagged or something like that. I want to see that you can competently write some software and you pretty much know how programming works. All right, so don't expect trick questions. And if you're taking the exam and you think there's a trick question, come up and ask for clarification because it probably was not intentional. And I'll try to point you in the right direction so I can see what you can do. Okay. Be able to work with strings, we already mentioned that. The empty string, important tool for us. Certainly be able to work with string concatenation, gluing strings together. Difference between instance and class methods, know how to call them, know how to write them, know how to identify them when you're looking at the definition of one. So when you're looking at the definition of a method, if you see static there, it's a class method. If you don't see static there, it's an instance method. When you're seeing a method being called, if it's being called with the name of a class, it's a class method. If it's being called with an instance of a class, it's an instance method. Those types of things. Be able to identify these things and be able to call them if you were given the kind of the rules or the documentation. There will probably be at least one question on there that will test your ability to read the documentation. I'll probably give you some sort of fictitious class that doesn't necessarily exist I'll say, here's the method header for it. This is what it returns. Here's its name. This is the class in which it lives. Show me that you can use this, and I'll give you, something that it does or something like that. All right, so you'll have to show me that you don't necessarily need to have been exposed to the tool before in order to properly use it. If you walked into Home Depot and you see a hammer or something like that, that you never used before, some kind of special hammer or whatever. You kind of have an idea of how to use it because you see that, it has a handle. I'm probably supposed to grab that and that kind of stuff. So you should be able to use things by looking at the documentation and identifying, is this an instance method or a class method? Okay, how do I call it? What do I need to do in order to call it the way I'm supposed to call it? That kind of stuff. So calling methods, blah, 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 defining methods, identifying methods, all the stuff we just talked about. Certainly some of our common methods from the string class you should be comfortable in using. So index of and char at, those two string methods are pretty important power tools. And I'm sure one way or another they'll be represented on the exam. Probably not directly. I probably won't ask you what does the index of method do, but maybe one of the functions that I have you write. I say write a method that does X, Y, or Z. The expectation would be that char at and index of are going to be in your go-to moves for how to solve that particular problem. Okay, so they will, the three things that would probably be very important for you to consider on certainly anything dealing with strings would be whether or not the empty string is going to play into your solution, whether or not index of will play into your solution, and whether or not char at will play into your solution. And then again, along with loops, because we've worked with a lot of collections, whether it's strings or whether it's arrays, looping through collections of data and doing something with them is also a important type of skill. Okay, so those are kind of, if you think about the problems we've solved and you start seeing those same trends that we've done over and over and over again, manipulating strings, spinning through all the elements of an array, those types of things are probably going to be represented in some of the programming questions on the exam, as opposed to something just completely from left field or something like that. Certainly understand the difference between comparing strings with double equal sign versus comparing strings with the equals method. Remember, the double equal sign compares the memory address. Are these two the same string, as opposed to whether or not these guys are have the same content? I would say that's medium priority. That wouldn't definitely make it onto the exam, but that would be fair game. That would probably be on the exam ahead of some of the other things I said low priority on. Knowing that you can't appropriately compare strings to each other using double equal sign. That does not look at the content. It looks at the memory address. It tells you whether or not they are the identical string. Pointers again. I mean, the idea of a literal, I won't ask you anything specifically about that, but we're used to working with literals. We're used to working with numbers. We're used to working with chars. Those are all literals, just the values. A is a thing. We didn't define it. It's a letter in the alphabet. It's one of the characters in the Unicode set that is a literal. Like same thing with the number 5. We didn't invent the number 5. It's a thing. Okay, that's a literal. Certainly the new keyword, be familiar with that. I doubt I'd ask you a direct question like, what is the new keyword? But you should know that it's our real estate agent. It goes and requests memory for us. It's always going to return a memory address. So be familiar with what the new keyword does, because you probably, well, you almost definitely have to use it in some of the methods you'll write, and understand that things that involve the new keyword are going to be passed by reference, because you're passing a pointer, a memory address. New keywords are how pointers are created. Again, number conversion stuff. Certainly this keyword, be comfortable with that. Be able to use it. If you remember from kind of the midterm, I had you write a class with kind of an appropriate constructor, and I expect you to say, like, you know, this dot first name is equal to first name, this dot last name is equal to last name, that kind of stuff. So understand what differentiates a variable name from this dot variable name. You know, this is how an object refers to itself from within itself. Similarly, super, which is your parents' how you refer to the instance of your parent from within yourself. And more recently, we've been looking at super in terms of calling our parents constructor, or we called our parents two-string method when we wanted to kind of implement our own two-string, and then redefine that by calling our parents so we get the memory addressy thing as well. So be comfortable with those two, but certainly very comfortable with this. Super is more situational, but this is really common. Be comfortable with arrays, be able to create them, be able to fill them with stuff, be able to do things to them. I probably will not ask you to do something like I wouldn't ask you to write like an insertion sort or a merge sort, something like that on the exam. So I don't want you to spend your time memorizing those algorithms. You know, if I wanted you to implement an algorithm for something, I would give you the algorithm. I'd say, here's how this works in English. Give me the, you know, the equivalent code to do something like that. So don't spend your time memorizing what merge sort is or memorizing what insertion sort is. Possibly you might have to sort an array using the stuff we've been dealing with recently, the comparable interfaces and things like that. So you'd use arrays.sort. To sort some stuff. So that should be a skill that you're familiar with, but not implementing the algorithm for a specific sort. That's more testing that you understand how interfaces work, that an interface for comparing things requires you to implement, well, the comparable interface requires that you implement the compare to method and what kind of value that compare to method is supposed to return. Less than 0 if the value that's calling it is less than the guy that was passed in, greater than 0 if it's greater than the guy that was passed in, equal to 0 if it's the same value as what was passed in. Certainly you should understand how arrays work in contiguous memory. This would be, you know, medium to low priority. Again, this isn't going to necessarily meet, I mean, this is important stuff that I want you to understand. Arrays are fast because they're in contiguous memory. You know, you can calculate bucket 2 by going to the base address of the array where it lives in memory, adding to it 2 times the size of whatever kind of value you're storing. That gives you your final memory address where the value you're looking for lives. That's all fine and dandy. It is important stuff, but isn't really what I'm testing on the final exam. Okay, that's under the hood stuff. I want to see what your competency is for applying the knowledge you've learned in here, as opposed to, you know, eventually this wouldn't be a memorization thing, but I probably would not waste your time. If this isn't already clear to you, I wouldn't waste your time trying to memorize what's on this slide to spit it back out. It's not going to be on the exam in this form. You'll certainly have to use arrays, but not, you know, you won't have to dissect an engine of a car on the exam to tell me how it's actually working. The closest we might get is if I asked a question like, what does it mean for arrays to be represented in contiguous memory? Something like that, which means that under the hood, arrays are all the buckets of an array live next to each other in memory. Something like that. But you wouldn't have to go into the depths here. And I also don't think I would ask that contiguous question, but if I was grappling for an extra question and I wanted to get onto that topic, that would be the type of question I would ask related to it. All right. Same stuff. Inheritance, and now we're starting to get into some of the stuff that it was kind of post midterm that we've been working with more recently. So the idea of inheritance, everything comes off that top level object that's built into Java called object. So if we write our own object and we didn't specifically say this guy extends something else, it automatically extends object and gets all the stuff from object, specifically this toString method, which the println method then uses to print out any object. So if we didn't do anything special, every object is printable by calling system.out.println on that object. And what it will do is it'll look locally in that object, not find toString. It'll eventually work its way up to the top level object and see that, oh, there's a toString there. What does it do? It spits out a memory address looking thing. All right, so understand how those guys kind of work together, and that if you want your objects to be able to print themselves using println, you have to implement your own version of toString that does what you want it, like printing a patient, maybe prints the patient's first name and last name, that kind of thing. So you would have your own version of toString that would hit first, it would find first before it bounced up to the object version of that guy. Okay? Again, super keyword, lower priority than our this keyword in the big scheme of things, but still important. Okay, this kind of is how inheritance is implemented in these modern languages. Here's like that question before. Objects are collections of fields, methods, constructors. Those are the things that live inside of objects. The concept of coupling, I probably won't ask anything specifically about it, but one of the goals in programming is we want to have our different parts of our program as unreliant on other parts of the program as possible, that type of stuff. Sometimes it's unavoidable, but if an object that you write can stand on its own, that means it's more general purpose. So an example of coupling in real life might be if you have you know how they have the at gas stations, they have I guess it would be an older gas station that has like the bathroom outside, and you have to go in and get the key for it. And the key's like attached to like a baseball bat or something like that because they don't want you to run off with it so you won't fit in your pocket. That key is coupled to that baseball bat. Those guys go together. Okay, so if you want that key, it's you're dragging the baseball bat out there. Kind of a roundabout, weird, but accurate example of coupling. So if you have two objects that are linked to each other in some way like that, one isn't any good without the other.
If you want to get the key, you have to buy something like a bag of peanuts.
Does that still happen?
I think so.
Yeah, that would actually make sense. Like how bad do you really have to go? They don't really exist anymore, though, right? Or at least not very commonly. Those are kind of the gas stations you don't want to stop at.
Right. It's been a while, but I feel like I have been places where, they're still like, you gotta buy something.
Okay. Yeah, my standards change. When you get married, the places you would have stopped at before are become off limits places now.
So, are you in places that sell porn in the bathroom?
Certainly not that, but yeah, I mean, and it goes to restaurants too. There are restaurants I would go into with my buddies. They're like these hole in the wall places that usually have pretty good food that I would not take my wife into.
Right.
So I don't know. Life gets boring, I suppose. It's recorded. It's fine. I don't regret it, but it does get a little boringer. A lot boringer. Have any of you actually met my wife? Oh, just to see who would. It's like, man, what does this lady put up with? Yeah, people at church all the time say my wife is a saint for putting up with me. My wife's Uh, I'm recorded, so my wife's great. We've been married. What's up? Oh, well, actually, it's a geeky love story. So we met on the internet, but keep in mind we're older, so these aren't like these dating sites didn't exist because sites didn't exist. The World Wide Web wasn't a thing then. So we met in an IRC chat room. How many of you have ever been in an IRC chat room? All right, so it's not very common today, but it's like an old chat room. So we met in there. I was at University of Illinois, and she was at a community college near where she lived, and so we were chatting on there, and then ended up meeting in person. And then it was normal dating from there. And then I asked her, it was right after I broke my back. So I had this, I have a live picture of the proposal. So I'm wearing this back brace. I could like barely walk, but the appropriate thing for us to do when I just broke my back and I could barely walk was visit my grandparents and walk around Disney World. The best thing to do. It was planned ahead of time before the, yeah. So I proposed right in front of Cinderella's castle, the big circle thing. And we have a live picture because my grandparents knew that was happening, so they had the picture of the whole thing. So then people were like standing around cheering and stuff, and then I couldn't get up because my back was spasming, partly from the injury, and then also I was nervous and stuff, right? So you're like, you get tense. In fact, I actually don't think I kind of fumbled over my words if I remember correctly. I might have asked her to be my husband. I mean, I don't think that's a lie. I think so that was that. I definitely got our phone number wrong at our wedding when I was like, talking to the photographer person or whatever. I mean, I think I got very few digits correct. But I didn't feel like I was nervous, but I clearly was. I don't know. So it's not all that sappy, more geeky, I think. Huh? In pain, horrible pain. I needed somebody. I mean, at that point, I was like lifetime injury. I needed somebody to take care of me. So it was out of desperation. No, I don't think anybody else would take me. She is a keeper. What better be now? Or like almost 18 years in. Disney World existed back then. It's a thing. All right, so coupling. All right, so yeah, I probably won't ask you a direct question about coupling, but in the back of your head, you should kind of, especially next semester, most of you are going to be taking the software engineering course, right? 370 next semester, and like I already pitched before, strongly encourage you to take the 300 course. Especially when you're in the 370 course, because you're going to be expected to do some stuff in there that we're actually going to be learning in 300. A little bit backwards, but it is what it is. Take the 300 course. It will benefit you. Okay? So in any case, coupling is really a concept that becomes more in the forefront in there. When you're thinking about how to plan out the solution to software, you want to make things as loosely coupled as possible so that most of your parts are reusable. Okay? Exception handling, we dealt with tries and catches, and we dealt with runtime exceptions. I probably will not ask about that on the exam. Very important. We should definitely know about it, but goes a little bit against what I'm trying to accomplish on the exam. Okay, so when you're studying and you're trying to figure out what I might ask and what I might not ask, try to keep in mind that I'm trying to figure out what your current programming competency is. And that has less to do with these kind of sidetrack little things like this. Not that exception handling isn't important, but your ability to show me that you can handle exception handling or not doesn't necessarily tell me a whole lot about whether you can program. And what I'm looking for is what your competency in programming is. Because at the end of the day, I have to give you a grade based on how well you've mastered that material relative to what you should be coming out of this class with. Okay, and regardless of all this extra fluff that is important, programming is the skill set that we're really looking for, not special moves. Okay. Certainly be comfortable with the loop keywords here. I mean, obviously your functions are going to have a return in them for anything that returns a value. But break and continue might pop up in there in one of the programming questions. I doubt you will have a programming question that would, I mean, actually, I think it would be impossible for you to have a programming question. Impossible is not true. You wouldn't have a programming question that would absolutely 100% require you to use break or continue. That might be the most convenient way of solving it, but there would be another way out. Because typically you're using those to either move to the next iteration of a loop or to dive out of the loop unnaturally, if you will, to get out of the loop early. Where you could, as an alternative to break, you could always, if you have a for loop that's operating off a variable I, you can always change i's value to be something that will cause the Boolean expression to fail the next time through. And that's roughly equivalent to a break. It's at least functionally equivalent to a break. So be comfortable with those guys. Know that break immediately exits a loop. Continue immediately stops the current iteration through the loop and moves on to the next iteration through the loop. So things like this, these are the types of programming questions that I would ask on the exam. Write a function that takes a string as a parameter and counts the number of vowels in that string and returns that count as an int. That kind of stuff. All right, maybe not that exact question, but along those lines in terms of the difficulties. Recursion, we should definitely know about recursion. I probably will not ask you to write a program that has recursion in it. Not that you shouldn't be able to do it, but again, if my goal is to test your programming competency, recursion tends to be one of those topics that programmers kind of get last. It's one of those things they finally kind of catch on to later on in their programming career. All of you who end up, or at least CS majors specifically, not IT, but CS majors, and you take the 470 programming language theory class with me when you're seniors, you'll get very good at recursion in there. But for right now, you should know what recursion is, probably be able to solve the simple problems like factorial recursively or something like that. But on an exam, it's probably not going to tell me a whole lot about your programming competency because recursion is just a little confusing. So I probably will not ask you a programming question that requires you to use recursion. It would, if I brought recursion up, it would be more of like, what is recursion? When a function is implemented in terms of itself or when a function calls itself from within itself. I doubt I'd even ask that, but let's call it low priority, but that would be the form recursion would take on the exam, not in a programming question. So there's our example of factorial. Merge sort we used recursion for. So second half of the class, we've reused a lot of those things we learned in the first half, but we've done it now in the context of Android programming. So I will certainly the idea of design patterns will be on there. I'll probably ask you something about MVC. Might even ask you to explain how Android Studio accomplishes MVC. I probably won't ask you a direct question about an activity. Again, I'm not testing you on your competence to write Android applications in the big scheme of things on the exam. Again, I'm testing your programming competence. We chose to use Android as a tool the second half to add some interestingness to the material, right? But still, under the hood, we were writing programming logic. So I probably will not ask you a direct question like what's an activity, because that's more of an Android question than a programming question. Same thing with the R class. That's an Android specific thing. Same thing with GitHub. I mean, if any of those GitHub, I suppose, could, if I was desperate for a question, I might ask you to explain what the difference between Git and GitHub is or something like that. Pretty low chance that's going to show up on there. I think I have plenty of other questions I'll be able to ask because, again, that's a professional competency that you do need, but doesn't necessarily tell me a whole lot of where you are as a programmer. Same thing with view groups. Probably won't ask you a direct question about view groups or views. Could be something like, what's the purpose of an intent? Because this might fall into a question when we talked about singletons. So maybe how do you share information between two activities? Your options would be use the extras as part of an intent or use a singleton. Tell me what a singleton is, something like that. So that's kind of more of a programming concept of we need to share information between two objects, in this case, two activities. So how do two things share information between the two of them? What are our options for passing information between two activities? So something like that would have a much higher % chance of showing up on the exam. In fact, probably will be on the exam in some form. So here was our singleton rule of thumb. So as long as you kind of show, if I ask a question about singletons, as long as you give me a general idea on what a singleton is, that would be okay, because we've kind of advertised it as, the idea of a singleton is it's a good idea to keep something that needs to be shared among multiple objects in a single place. Well, then we have to give a little, and let's call that the official definition. Well, what does multiple mean? If you only have two objects that you need to share something, maybe a singleton is overkill. Especially when you consider if you have a large application, that singleton might get filled up with other things, as opposed to if you have something you need to share between 5 objects, definitely singleton. But 2, maybe you just pass it directly through the put extras mechanism. But officially, as long as you kind of give me this idea that, hey, a singleton, it makes sense to put something in some sort of locally or globally available storage place that you need to share among more than one place. I think that's a fair enough type of thing. Coupling came up again. Lately, we've been talking about interfaces. So maybe the difference between the interface and a class, that an interface is not an implementation, but rather directs the implementation of something. So it's possible that I might give you an interface, might be a real interface, might be a made-up interface, but I might say there exists an interface called somethingable, and it does X, Y, and Z, and mandates that you write a function that does this. So then you would write a class that has that function that you would say you implement the somethingable, and you would write that function, and that function would have to do, what the thing said it should do. Like the compare to function has to return an int less than 0 if the thing was less than the thing that was passed in, greater than 0 if it's greater than the thing that's passed in, equal to 0 if they're the same, something along those lines. So be able to work with interfaces. At the end of the day, they're pretty simple. I probably will not ask you something about the serializable stuff. Remember, we were working with intents, and if we wanted to pass an object through the intent system, we had to say that intent was serializable. We had to say that object was serializable. Did not require us to implement anything special on it, but it kind of flagged it to be turned into a bit stream. It was easy to work with, but again, this doesn't necessarily test a programming concept. It's more of an important programming concept for us right now. This is more of, if I want to use extras to get an object from point A to point B, how does that work? You would use the serializable interface to pull that off, which is nothing more than just throwing implement serializable at the top of your object. So first of all, not much to ask about. Secondly, very special purpose, almost like exceptions. So don't expect anything with serializable to be on the exam. Here's that pointer example stuff with your singleton. Again, I probably won't ask anything about view groups. So not that Android will be completely unrepresented on the exam, it's going to be vaguely represented on the exam. Right, so I won't ask you things about linear layouts and vertical linear layouts, and that kind of stuff. That's probably been the easier things that you've worked with, okay, but isn't a programming skill set thing. Kind of the goal of object-oriented languages kind of goes with the coupling stuff. I probably won't ask you a specific question about that. That's more of maybe a 200 type question, but we did throw it back out there, so read the slide when you're studying it, but don't necessarily study it or memorize it, whatever. Just recently, we looked at the idea of generics. That won't be on the exam. We will definitely use generics next semester. But just so you're aware how generics work, we did use it for the comparable interface. If I wanted you to use it on the exam, I would probably give you the syntax for it. Okay? Or I would just ignore it if you didn't put the generics part of it in there. Not an important concept that I'm wanting to test you on. Last class, we talked about abstract at the very end, and we haven't really seen it in action at this point. But when we make a class abstract, what we effectively are doing is we're saying this class's sole purpose is to support inheritance. Nobody will ever create an instance of an abstract class. And we saw an example last time with the person class, right? We decided that, it never actually makes sense for somebody to be a generic person. They're patients or they're athletes. They're something else, something more than just a generic person. So therefore, we might say a person should be abstract. That way we don't accidentally create a generic person. And then we'll inherit from that abstract class to give ourselves the more specific, give ourselves patients and things like that. So I suppose abstract could show up on the exam in like a question of what's the purpose of an abstract class, something like that. I wouldn't ask you to write code with it, even though that wouldn't be a major deal, just we haven't had the practice doing that, so it's not going to really get me what I want in terms of measuring what your current competency is. Probably fairly low priority. I think I'll have enough other questions to ask, but it's not a real hard concept to remember, but it will not be there as a programming question. If it's there at all, it'll be just more of a what does it mean for a class to be abstract type question. Okay, so questions about the final exam. Make sense to everybody? So we're all going to get A's, solid A's, high A's. Remember that the final exam, if you do better on it than you did in your midterm, it will replace the grade that you got on your midterm. It's not average, it will completely replace it. So if you got a 10% on your midterm and you get a 90 on your final, it's as if you got a 90 on your midterm. Okay, so you can undo a mistake. So hopefully some of you will be able to do that. And we'll, I guess, see what happens. Yeah.
Do you take out the midterm or do you change the grade?
I changed the grade of the midterm. Yeah. So the midterm's still worth 20% of your grade, but it'll just be a higher value for it. Anything else? Going once, going twice. All right, I will see everybody next week.